Welcome back, everybody. In part 2, we're going to go ahead and start replacing some of the capacitors and some of the resistors. We're going to find some discrepancies, some more that, from the schematic that I'm using than what's in the radio, but I think we've got that worked out, and we'll see what all we can get into. So grab you some popcorn, sit back, relax, and keep your eyes peeled. These filter capacitors in this it's wax covered case, it's a cardboard pretty much, is soldered here and here with 2 tabs. I'm going to try to desolder that, and I'm going to try to take this out in one piece, restuff this, and put it back in the same position. I was able to take my soldering gun and heat this up enough to get it out. Now, if I could get this open without destroying it, that'll be another story. Well, I've got it out. All these are the tabs. This hangs around the edge of the chassis, and then this solders. They both solder on. If you can see in there, it's packed with wax. I'm going to try to take an X-Acto knife. I may heat this a little bit with a hair dryer. Nothing, anything that'll, you know, get it really that hot like a heat gun. But then maybe take an X-Acto knife and cut down there and maybe be able to open this box. I don't know. We'll see. I didn't use any heat at all. I just used that X-Acto knife and was able to break that out. So the big thing is going to be getting these. Sorry if I'm not on camera. I don't want to tear the box up. And if I can get these leads out of here, I might be able to heat this up enough to pull this package all the way out. Pull all the capacitors out of there. I wasn't able to get everything out of it. I could probably drill and dig, and I may take my drill and drill a little bit more down in here just to get a little bit more space. But what I think I'm going to do is I've got 2 4.7 microfarad capacitors at 450 volts. And what I think I'm going to do is I think I will put one in that side, one in that side, bring the wires out back through there, and put it back in there. Do I use the same wires, or do I the wires I think are good. I think I'll use the same wires. What do you think? Got the capacitors in there. We'll fold that over, and hopefully we can put the lid back on. I have to work it down like that. And now we have, and I'll test it with my capacitor checker. I may put a few drops of beeswax in there just to seal it up, just to keep it together. And there we have one rebuilt filter capacitor box. It's not called a can. Tacked in the filter capacitor box. Soldered in a couple of places. I think you may be able to see it here. one on the end, hangs over the end, and then this one just tacks to the. So now I've checked that with the capacitor checker, and each one of them is right around 5 microfarads each. So we'll just have to wire this back in, solder it in. We've got a brand new filter cap. Looks like it's untouched. As you can see, I've got all the capacitors replaced. Put the safety cap here, rebuilt this, got it connected back the way it was. I want to say this about that. When I said I went through the schematic and found the only difference was the 1 meg resistor instead of the 2 meg versus the schematic, I was reading these resistors wrong right here. Sorry about that. These 2 resistors right here, I was reading them wrong. I put some feelers out, various people, and I went on antique radio forums and put it out, and a couple of guys, I appreciate them answering me, and I didn't much want to believe it. I had this certain thing in my mind. I had a certain thought in my mind that, let's say this was the first band, the green, which made it a 5, which would match the 50 or the 50K or the 500K. That would match. So that's what locked in my mind. Okay. Then the second band would have been red. That would have been 2. So that would have been, in this case, this would have been the 52K, which was close enough to the 50K. All right. And I knew that if you look, the only difference in this resistor and this resistor is that band. This one's yellow, this one's orange. So I said, well, that band is the multiplier. Okay, having said all that, and then the other red band, I was in my mind was 2% tolerance. But after a little research, 2% tolerances didn't come out in this time. So after reading the responses on ARF, I tend to agree. And when I checked these, this one showed 300K, this one showed 30K. So if they were 500K and 50K, they went down in value, which that is not, that it can happen, I guess, but not both those. So the best I can tell is it's going by the old color system where it's the BED. Okay, you're saying, but that resistor is white. Instead, now this is, I'm making this up, this part of it up. It's the only thing that makes any sense. Is instead of painting the whole thing red, they painted a red band on either side of the multiplier. And that would be the body, which would be a 2. Then this would be the end, which is a 5. So we got 2, 5 with the multiplier of 10,000. So this one is 250K. If it increased in value, it would be around 300. It could be 300K. This one, the 2 red is the body, which is 2 with the 5. That's 25 with the multiplier. That's 25K. And it's increased to 30K. So, what I'm going to do is I've checked them, and they're both within 20%. Okay? So, I'm going to leave those in the circuit for now. And then when we bring it up, if the voltages and everything and it works correctly, then I'm going to leave it. Or I'll change them out to 25K and 250K, or the reasonable facsimile thereof. Okay. That looks fairly original except for the new capacitors. If you remember, we was having trouble with the on-off switch, and this is the volume control, the 10K, and the center of it is soldered to ground. I did some tests on it, and we've either got a bad spot in it or it's dirty. So what I plan on doing is I can access this to spray it when I take the front part of it off. So I'm gonna have to pry these up, and this is what I never like to do because they tend to break. So anyway, I'll take this apart off camera, and then I'll show you the insides of it, and then we'll spray it and put it back together. Okay, I've bent those back very so gently, and let's look and see what it looks like inside. See if I can get some light on it. Looks like a little dot. Most time it has a little tab, but this has got like a little round dot that goes up and down on it. So let's see. That's minimum volume. That's up. Okay. Let me take this outside and spray some deoxit in there on the switch. I may take the meter with me and make sure I get good continuity. I don't know if I've told you this or not, but when I spray any type of petroleum type product here in the basement, I've got some gas logs in the next room, and whatever it is, whatever odors in the air, and I'm talking just a psst, it will take those logs will take and it'll take hours to burn that scent off, and I don't. So I get in trouble when I do my little psst, when I'm down here. So I have to take things outside, and so we'll do that and try not to get in trouble. Got it put back together, sprayed it all out, and then I took my little piece of wood, and this comes from I don't know if I told you or not, Michael from That Tube Sound's wife. She did jewelry, and said if you're bending these tabs, use a piece of wood to bend them over instead of your pliers or whatever, and keeps from breaking them so often. But it's all back together. Let's get it back in the set. And, you know, we're getting pretty close to testing this thing. We're going to try to put some power to this, and I think I've got everything hooked up. I got an antenna hooked up, and that's optimistic, right? Got the cover off. I've got a couple of meters hooked up. Hopefully you can. We'll be several things we're going to be looking for. We're going to be looking at current right off the bat as we bring it up. I'm going to be looking at this one back here. The Fluke is going to show the B+. And then I've got this Radio Shack hooked up, and I've got that on the plate of the 76 tube. That is the one that we're unsure about, these resistors. Remember, I left the old ones in. One of them is 30K, one of them is 300K. The schematic that I'm using shows them to be 500K and 50K. These are less, which means they may have less voltage drop across them, so the voltages may be higher. That's based upon the schematic versus what we have in here. That's 40% off. So that's the reason I'm going to be watching the plate of this 76. Now the 76 tube is good. The maximum voltage on it is 250 volts. Of course, we're going to have, before that tube starts conducting, we're probably going to see more than that until that tube starts. But let's see if we can't bring this up. Got it down on 0. Let's start bringing it up. Hang on, I ain't got everything hooked up. Let's see, B plus is right there. Okay. All right, let's start bringing it up. Scared me, it went down, but I turned it the wrong way. All right, current's less than 200 milliamps. We're up to about 40 volts AC. I got all the way through all that, and then I realized that about 40, at about 40 volts, I ran out of memory. So I reviewed it, realized I got my head all in it, and that all this junk was over here. So I cleaned that up and moved the camera to where you won't see my head so much. So anyway, sometimes reviewing it is a good thing, but here's the bad thing is I already know what to expect, and I really wanted to capture that on the first time. So anyway, so I'll have a little bit more confidence bringing this up if that is an indicator. So we're going to go on up from 40. We're going to go on up to about 75 or so. We're starting to see some B plus. The plate is just peaked up at about 160. It's dropped back to about 120 for now. B plus is still low, but we're still at about 75. Let's bring it up a little more. Starting to hear a little bit of noise. There's about 100. Current is less than 400 milliamps. We're looking good on that. B plus is about 180 or so. So we're going to bring it on up. Right at it's about 8:30 in the morning. Current's about 420, 410 milliamps. B plus is looking about 108 or 208, and the plate is just shy of 150. So that was a concern. So let's, obviously it's working. I hope we're in the right band anyway. I'm really surprised. I thought that the band would be gone by now. That's the top end. Going down the band. There's the low end. There's not a whole lot there. Okay, here's something on the volume. It's going into oscillation when you turn the volume. And if you look on the schematic, you'll see that the 10K resistor is affecting the bias on the 6D6. We have two options, I believe. Well, not options. This is the original potentiometer. A lot of them, and the schematic does not show it, and it wasn't in this circuit, a padding resistor to, even if you zero out the volume control, it won't go to 0 ohms. There'll always be at least 300 or 400 or whatever it is to provide the bias to that tube. Sometimes the potentiometer has a stop in it that allows it to stop at a certain point. There was a stop in there, but I can't remember what it was, if it was set on anything. So we can probably check that with an ohm meter, run it all the way down. If it goes all the way down, then the stop is either not working or it's not right. Okay, I've got the meter hooked up between ground and the cathode of the SD6 tube, and we're going to see what the minimum bias on this. Remember, I said that I may have said the grid bias in the last video. I don't know. I'd have to go back and review it, but this is the cathode bias of the 6D6 tube. We call it a 10K resistor, but it's marked, it's stamped on the potentiometer as 11K. So there's the top end of it. So let's go all the way to the other end and see. And there's 177 ohms is the minimum resistor in that cathode. So that stop is built in to that potentiometer. And you'll see in circuits sometimes there'll be another resistor beside that potentiometer. Well, this particular one is built in with a stop. It'll only go to a certain point, and it's roughly, this one's roughly 200 ohms, and a lot of them you'll see on the side will be 200 ohms or so. That's to maintain that much resistance on the cathode for the bias, so it won't go all the way to 0. So I hope that clears that up. Now, if you replace this volume control with just a regular potentiometer, you're going to have to put a resistor on the end of it to keep that bias, that cathode bias, proper. There's not a whole lot on aligning these TRFs. There's two trimmers on the side, and maybe we can adjust that to keep it from going in if it is oscillation. So let me disconnect all this stuff, and then we'll come back and we'll see what about trimming those out and see if we can get rid of that. Because what happens is you can see as it goes up, it goes into oscillation. So I feel like we may be able to trim that out. Okay, let's see if we can adjust these two on the very end here. They're not even on this schematic, but I've got the very weak station on the not on the very upper end, but more towards the upper end than the lower end. And let's bring it into, I want to bring it just barely into oscillation. Okay, let's see if we can bring, what I'm doing is I'm alternating between the volume and this cap to bring it out of oscillation, to get the volume controlled louder with a weak signal without it going into oscillation. There it goes into oscillation. Let's try this one. Okay. Okay, there's the max volume.
For your investment, get your project today and talk to
max volume, and it's operating now. So we can go through here and retouch this a little bit and maybe refine that a little bit, but that solves that problem there. I'll go back and look at the voltages. I don't know what it done for the low end, but of course there's not much to receive on the low end. I got a lot of buzzing. I need to that's probably it. A lot.
Here, Sugar Mountain's brain.
Okay. I think we can work with this. I'll go on and see if I can find some procedure for tuning a TRF receiver. But I think we're going to wind this one up. If I find anything that definitive about aligning this, we'll do that. But I think we've got we've got it working. Sounds pretty good. The voltages look pretty good. So in the next series, we'll smooth up. I'm not going to refinish the cabinet. I'm just going to let it. I'm just going to maybe put some restore finish on it and let it go. And we may in the next one we'll work on that dial, try to clear up those lens, and try to get this dial string and everything working back again after the alignment. So gonna wrap it up for now. So from Larry from the hills of Tennessee, thanks for watching.